What does it take to subnet a network? Some people say this is a very complex topic and very difficult to comprehend, but we set out to make this very simple. What does that mean, subnetting? Subnetting means that you have a network and you want to turn that one network into more than one network. So you have a network, you're going to turn it into subnetworks. That can be any number of subnetworks within a certain limit. Now, if you bring up your IP configuration from your device, I'm going to bring mine up now. What I see here is that I have an IP address 10.0.0.160. I have a subnet mask 255.255.255. That's all I need to subnet my network. But the first thing I need to know are the rules of subnetting. Up on top here, you can see you can't use the first IP because that's called the network address. You cannot use the last IP because that is called the broadcast address. The network address represents the network. The broadcast address represents all of the devices on the network. If ever there is traffic to be delivered to all of the devices, it will be sent to the broadcast address. So you can't use those two IP addresses, but you can use everything in the middle. So with that understanding, I set out to find the first and the last IP of my network. Given that my IP address is 10.0.0.160, as you saw from my computer, and my subnet mask is 255.255.255.0, I can now understand how many IPs I have in that subnet. Realize here that instead of writing just 255.255.255.0, I also put /24. It means the same thing. One might wonder, why /24? Well, it is simple. You know 255 is 8 ones in binary. You have that 3 times. 3 times 8 is 24. Now, if you had that 25 times, you could change that to 25. And we're going to have it that way very soon. So the first 24 bits of my subnet mask are on. That's what we see here, and that's why we have /24. And I want to find, number one, the first and the last IP of that subnet. It is simple. Because the IP address, as you saw from my computer, was 10.0.0.160, I now understand that I'm only working with the last octet because the first 3 octets are saturated, as the subnet mask says. Only the 4th octet can be changed. So the change is going to happen only on the 4th octet here. So which IP will be the first IP of this network? Very simple. The first IP will be 10.0.0.0. I am somewhere in the middle, 10.0.0.160. So what will be the last IP? Very simple as well. All we need to do here is to convert all of these, right, from bits that are off to bits that are on. If we turn all of these bits on, what do we have here? We have 255, right? So that means the last IP address will be 255. Now, that is the range of IP addresses in my subnet, in my network, this original network that I have. That's a total of 256 IP addresses, given that I started at 0. Now, I cannot use the first, nor can I use the last. So the usable IP range for me will be 10.0.0.1 all the way to the one before the last, 10.0.0.254. Now understand that the requirement for me here is to break this network into 2 networks. If the total IP addresses that I have in one network is 256, then the total IP that I have in each one of the 2 networks when I break that big network to 2 smaller will be half. That will be 128. And one of the things that I will need to achieve that is to turn one more bit on in my subnet mask. The minute that I do that, I turn one bit on, I double the number of subnets that I have. And this cheat sheet here tells you what you have. When you had 24 bits on, you had 1 subnet, and you had 256 IP addresses, and you had your subnet mask in the last octet 0. Now that you turn one more bit on, you're going to have now 25 bits on in total, and that's what we represent here. Now, when you have that number in binary, you know what that number means. In binary, it means 128. Then your new subnet mask now will be 128, right? 255.255.255.128 or /25, same thing. Now, instead of having 256 IP addresses, you're going to have 128. That's what you have here. Now, that's not the reason why you have 128, make no mistake. The reason why you have 128 is because if you were to turn all of these bits on, what you would have here would be 127, and you would add the network address to that. That would give you 128. So let's do that. Let's find the range of IP addresses in each one of these new subnets. You're going to start the first range with 0, and you're going to stop at 127 because you have a total of 128. From 0 to 127, that gives you 128. In the second range, now is going to start from 128, the next IP in line, all the way to 255, the last IP in line. You know you can't use the first IP, nor can you use the last IP. So 10.0.0.0 and 10.0.0.127 are not usable by any host. So you have 10.0.0.1 to 10.0.0.126 that are usable. So here we had 254. That's what it was supposed to be. In this range here is going to be 10.0.0.129 all the way to 10.0.0.254 that are usable. Remember that 255 will be the broadcast address and the 128 would be the network address. And your subnet mask will not change. It will remain 25 for both subnetworks. This is how you subnet a network. Now, I created this cheat sheet for you here because we are focusing only on subnetting the fourth octet of an IP address. You could also subnet other octets, like this octet over here or this octet over there, but we are only concerned about the fourth octet. So, make no mistake, when you do that, you have now broken this network into two subnetworks. But what if you wanted more than two subnetworks? What could you have done to accomplish that? Well, what you could have done here is instead of just turning one bit on, you would now turn a second bit on. If you do that, you will double the number that you had before. Now that you had 2 when you had 1 bit on, if you turn 2 bits on, you're going to double from 2 to 4. And your CIDR notation, which stands for classless interdomain routing, would be now 26. And the number of subnets you would have would be 4. The number of hosts or the number of IPs per subnet would be 64. The subnet mask now would end with 192. You see the idea? Now, what if you wanted to have 8 subnets? All you would need to do is to turn one more bit on, and you can follow the rest. Your CIDR notation would be /27. Your number of hosts per, your number of IPs per subnet would be 32. Your number of subnets would be 8, and your subnet mask now would go from 128 to 224. And what's important is that you can always find the range of IPs in each subnet. And once you find that range of IP in each subnet, then you also know the range of usable IPs in each subnet because you're going to remove the first and the last IP in each subnet. That is it. I invite you now to bring up the IP configuration of your own device and subnet that IP find the whole network. From that IP and the subnet mask, find the whole network. And once you do find that, now subdivide that first into 2 subnetworks, then into 4 subnetworks, then into 8 subnetworks. Show me the usable ranges for each one of those subnetworks in the complete range as well, including the first and the last, which would be the network ID and the broadcast ID. This is how you subnet a network. And now you can assign each one of the subnets to a particular group of devices. You can say, okay, this one, I'm going to use this for the guests. This one I'm going to use for employees. These others I'm going to use for investors. And I'll use the fourth maybe for something else, or for servers, for instance. As a result of that, you start segmenting your network. Segmentation is a very important topic in the life of network engineers because it helps take control of the network and prevent malicious actors from reaching areas of the network where they're not supposed to reach. You think about our network. You're a student, so you have access to what we want you to have access to. That's why there is a subnet associated with the students. Once a student logs in on the VPN, then they're assigned an IP on that subnet. And as a result of that, further in the network, we can control where the student goes and where the student cannot go.